Right, so here in 5.3, we're going to talk about higher derivatives in our concavity and second derivative test. So we have been doing the first derivative, and we know the first derivative is the rate of change of a function, also known as velocity, which is the rate of change over time. But what if we want to go ahead and know how the velocity is changing? Is the velocity of our function increasing or decreasing? And so we want to go ahead and take the derivative of our first derivative. So we want to take the derivative of basically our velocity, and we're going to also call this acceleration. All right. So when we go ahead and take the notate the second derivative, all right. Here's our first derivative notation, and our second derivative is the derivative of our derivative. And so instead of one parenthesis, comma here, we have two now, and we have our second derivative. For our Leibniz notation, it's also d squared y over dx squared. All right. And then we also have our function, our capital D of x squared function notation of our f of x function right here. And in order to go ahead and find our second derivative, we really just go ahead and take the derivative of our derivative we already taken. So we have a function, we take the first derivative of that function, and that first derivative, we go ahead and take the derivative again, which gives us our second derivative. And we can continue on in this way. We can go ahead and take the derivative of the second derivative, which is the third derivative, which is notated like this. And then we can also take the fourth derivative. We quit putting those little commas in there, and we start using a number in parentheses. And you could keep taking the derivative as many times as you would like. And polynomial functions are pretty nice. The derivatives go pretty smooth. But for some of our other functions, especially those that involve the chain rule, other things that can get really tricky and complicated. So we're also going to look at some applications in the second video involving the second derivative. But let's go ahead and work on finding our first derivative. So here we have, we want to find the second derivative of our function, and then we want to go ahead and find the acceleration when our x is equal to 0 and when our x is equal to 2. Right, so here we have a nice polynomial function, 5x cubed minus 7x squared plus 4x plus 3. We're going to go ahead and take the first derivative, so we're just going ahead and do that really quickly. 15x squared minus 14x plus 4. And then we're going to take this first derivative, and we're going to take the derivative again. And so we end up with 30x minus 14. And using our second derivative, we're going to find the acceleration at 0. When we plug in 0, we get negative 14. So at the x value 0, our acceleration is decreasing. And when we go ahead and plug in 2, we go ahead and get a positive value of 46, which means that this value, x equals 2, our acceleration is increasing. Let's go ahead and look at another example here. So here we have f of x is equal to x squared divided by 1 over x. And in this case, we're going to have to go ahead and use our quotient rule to go ahead and take our first derivative. So when we go ahead and use our quotient rule, we go ahead and have the derivative of f of x over g of x minus the derivative of g of x times f of x over g of x squared. We go ahead and simplify it, and we end up with 2x plus x squared divided by 1 plus x quantity squared here. Right. So now we have to go ahead and take this value here, and we have to go ahead and take the second derivative. And again, we're still going to go ahead and use the quotient rule. So when we go ahead and look at this example, we go ahead and we take our g of x right here, our f of x, sorry, times our g of x quantity squared minus the derivative of our g of x times our f of x squared. Okay, and then that's over our g of x squared, so that's going to make it a fourth power now. Right. What we're going to do now is we're going to go ahead and write our 1 plus x quantity squared, and we're going to write it in two separate pieces so we can cancel it out with one of those in the denominator. So now we're going to have a cube on the bottom, and we're going to have this 1 plus x is going to go ahead and disappear. Right. And then we're going to go ahead and combine all our like terms, distribute, and all of that. And everything on the top cancels except for a lone 2. And it's still going to be over 1 plus x quantity cubed. So it's usually better to try to cancel if you can before you start foiling, so it makes your life a little bit easier. Here again, we're going to go ahead and plug in our x value at 0. When we plug in 0, it does not cause us any problems, and we just end up with the number 2. So therefore, at our 0, x equals 0, our acceleration is increasing. It's positive. When we go ahead and plug in x is equal to 2, we end up with a fraction of 2 over 27. Still positive. Our acceleration is still increasing. It's just increasing at a slower rate. All right, so now we're going to go ahead and look at an example that involves the chain rule. So we have f of x is equal to the square root of x squared plus 4. And it's always easier, of course, to go ahead and write our square roots as fractional exponents, which equals 1/2. And so our first derivative is going to go ahead and be 1/2 times our value here, x squared plus 4 to the negative 1/2 power, times the derivative of the inside, which is just 2x. And this 2 from the 2x and this denominator here of the 1/2, they end up canceling out because it's just multiplication. You'd have 2x over 2. And then we're left with x squared plus 4 to the negative 1/2 times the value of x. And we can go ahead and use the product rule now on our first derivative. So we're going to consider our x squared plus 4 as our f of x, and our x by itself as our g of x. Okay, and so we're going to go ahead and take the derivative of our first piece, our f of x. So we have negative 1/2 times x squared plus 4 to the negative 3/2, and then times 2x, and times our g of x, which is just x. And then we're going to go ahead and add. We have f of x by itself here, x squared plus 4 to the negative 1/2, and our derivative of g of x, which is just 1. We're going to go ahead and get everything put together. So this first piece here, we have a negative 1/2. So we have a negative and the 2's in the denominator. This here is to the negative 3 over 2 power. So the x squared plus 4 goes into the denominator, gives us a positive 3 over 2 power now. And then our 2x stays on the top, and then we have another x, so that's how the x becomes squared. And we're going to go ahead and add that to our second piece here. Our x squared plus 4 is to the negative 1/2 power, so that's going to go to the denominator as a positive 1/2. And then times 1, we need to have that 1 in the top to make sure that this piece here stays in the bottom. And so now if we go ahead and simplify, we can cancel out these 2's here, and we write it as a negative. Now we'll keep the negative out here. It's just a little easier to deal with. We have x squared divided by x squared plus 4 quantity to the 3 over 2. And then plus our 1 over x squared plus 4 quantity to the positive 1/2. And now we have to be able to add these things together. So we need to go ahead and get our common denominator. And our common denominator is going to be x squared plus 4 to the 3 over 2. All right, and seeing as the first fraction already has that, don't forget there's a negative there, we could go ahead and create or get our common denominator from our second fraction by multiplying this by x squared plus 4, because if we add 1 to 1/2, we get 3 over 2. All right, so we're going to go ahead and add those two together. We're going to go ahead and leave this fraction alone. And we're going to go ahead and multiply the second fraction by x squared plus 4. You don't necessarily need to put the first power, but if it helps you keep track of what you're doing, please, by all means, go ahead and do that. When we go ahead and get this piece going here, we're going to have an x squared plus 4 on the bottom, and then we have a negative x squared here. When we go ahead and put those together, those x squareds are going to actually cancel, and that's going to take care of our negative, and we're just left with the 4 on the top. The denominators are going to be x squared plus 4 to the 3 over 2. It's going to stay the same because we created it that way. So we just have 4 over x squared plus 4 to the 3 over 2. All right, so our second derivative is just going to be this 4 over x squared plus 4 to the 3 over 2. So now we can go ahead and find the values of our second derivative at 0. And at 0, when x is equal to 0, we end up 4 over 4 to the 3 over 2 power. Going ahead and converting that back to a radical, we have the square root of 4 to the 3rd power. All right. When we go ahead, and remember we have to rationalize the denominator here. So we have 4 to the 3rd power, and we want to go ahead and rationalize the denominator. When we go ahead and rationalize the denominator, we have 4 over 2 cubed, which is just 8, which is just 4 over 8, which is 1/2. So if you have forgotten on how to go ahead and rationalize the denominator, you may want to go ahead and look that up and practice that a little bit, because that's going to happen quite a bit when you end up with these fractional exponents, so you can get a simplified answer. All right, so our acceleration is increasing just slightly at 1/2 at 0. At 2, then we go ahead and plug 2 in. We have 4 over 2 squared plus 4. So 2 squared is 4. So we have 8 here. 8 to the 3 over 2 in the denominator. Again, we're going to go ahead and have 4 over the square root of 8 cubed. And again, we're going to have to go ahead and simplify this. It makes our life a lot easier. And we want to go ahead and have our 4 over 2 square root of 2 cubed quantity. Okay, once we simplify, because the square root of, 8 times, 8 is 4 times 2, sorry. And 4 is a perfect square, so it comes out, which is where we get this from. And when we go ahead and do some math magic here, we end up with 16 square root of 2, which simplifies to 1 over 4 square root of 2. And let's look at this a little bit closer. So here we have 2 square root of 2 cubed. All right, and it's easier sometimes to go ahead and write this out 3 times. All right, and this is how we're getting the 8. Okay, so here we have an 8 from our 2 times 2 times 2. Our square root of 2 times our square root of 2 is this perfect square times 2. That's where the 16 is coming from. So the math magic is happening down here. This is our work. This is the simplified version of this. So you want to go ahead, if you really need to work with these and you're struggling with the radicals, especially when they're kind of odd like this, you can start off once you get it to here, or even at this point here. You could go ahead and multiply the square root of 8 times the square root of 8 times the square root of 8 and do the same process we did here, simplifying your radicals, and you should still end up with this square root, the 16 square root of 2. And just remember, you got to always simplify your fractions at the very end. This next video, we're going to go ahead and cover the rest of the examples that we have here.